In recent years, wildfires have become a pressing concern. In 2023, wildfires cost British Columbians over $817 million, impacting both financial and public well-being. Today, we are reviewing a study which showcased aerial LiDAR's potential in accurately mapping forest canopies, a crucial element for modeling fire behavior. We'll link the study in the description for you to review. The research team conducted a study over a Pacific Northwest conifer forest, collecting LiDAR data and using regression analysis to correlate it with field-based fuel estimates. The strong relationship observed underscored the LiDAR technology's reliability in fuel estimation. The process involves several steps: LiDAR data collection to create detailed canopy point cloud, followed by specific algorithms for estimating canopy fuel parameters. This includes dry weight measurements of live and dead materials in the tree crown, categorized by foliage and branchwood sizes, and utilizing the fuel and fires extension in the forest vegetation simulator methodology. The study quantified fuel parameters in various units: canopy fuel weight in kilograms per hectare, canopy bulk density in kilograms per cubic meter, and canopy and base height in meters. LiDAR-equipped drones can provide high-resolution 3D data of forest canopies, enabling the calculation of these metrics. These metrics are vital for understanding fire intensity and spread potential. The combination of drones and LiDAR offer numerous advantages over traditional methods, such as rapid data collection, reducing time and labor, and additionally, high-resolution data is more accurate, enhancing our understanding of the forest structure. Accurate fuel estimation is crucial for effective fire management, aiding in the development of fire behavior models, essential for predicting the spread and intensity. This information informs fire prevention, controlled burns, and suppression efforts. While the study used LiDAR-mounted systems on a helicopter, today's UAV LiDAR sensors are more affordable and accessible. Advances in technology like the ZenMuse L2 offer improved penetration into dense forest canopies, capable of up to 5 returns. Furthermore, software like LiDAR 360 can automatically extract advanced tree metrics and estimate biomass. The study exemplifies the potential of LiDAR data in forest fire management. As this technology continues to evolve, it will play a pivotal role in enhancing our ability to manage and mitigate forest fire risks. If you found this information valuable and want to learn more about the drone technology's role in wildfire management, please follow us for updates and don't hesitate to reach out to our team for remote sensing solutions.